Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Space Telescope has revealed light from beyond the Dark Ages, a period that began shortly after the Big Bang and lasted approximately a billion years. This epoch was once thought to be completely obscured by dense clouds of neutral hydrogen gas, preventing any direct observation of early galaxies. However, scientists have now discovered surprising sources of light from this era, indicating that our current understanding of the universe might need to be revised. Thanks to the James Webb Space Telescope, the mystery surrounding the Dark Ages has been clarified. The telescope's observations confirm that light was indeed present during this time. Webb identified Lyman alpha emissions, which are produced when ultraviolet light from young, hot stars interacts with surrounding hydrogen gas. Remarkably, this light has reached us, suggesting it was able to penetrate the dense hydrogen clouds of the Dark Ages. Researchers believe this was possible due to the formation of bubbles and channels of ionized hydrogen created by the first stars and galaxies, allowing the Lyman alpha emissions to escape. The initial detection of Lyman alpha emissions from this period occurred before the new space telescope was launched. Researchers had already been able to capture and study these faint signals from a largely unexplored epoch. Now, the Webb telescope is providing new insights into this discovery with its enhanced ability to detect and analyze Lyman alpha rays. The data so far indicates that the first galaxies and stars formed much earlier and on a larger scale than previously thought. Since its debut in 2022, the JWST has revealed galaxies that were notably advanced and luminous during the Dark Ages. The fact that these galaxies are visible suggests there was more light during this period than previously believed, and that Lyman alpha emissions were not the only signals breaking through the cosmic darkness. The observed galaxies show signs of intense star formation and are unusually large. This evidence suggests a revised view of the early universe, implying that if there were more stars in the past, the universe was illuminated and light permeable earlier than once thought. Given the current findings, scientists may need to reconsider the concept of the Dark Ages. One of the JWST's most notable discoveries includes two high redshift galaxies so ancient they must have existed well before the Dark Ages. Their age is so extreme that they might have been present even before the Big Bang. This suggests that our previous data may be flawed, as these galaxies possess numerous properties that contradict earlier models of the universe's origin. Additionally, another perplexing discovery is the presence of a supermassive black hole at the center of one of these galaxies, which existed just 400 million years after the Big Bang. This discovery challenges our current understanding of the cosmological timeline and existing theories of galaxy formation. As we investigate the true nature of Lyman alpha radiation, it is clear that Lyman alpha galaxies are vital for studying early galaxy formation and evolution. The task now is to decipher exactly what these emissions reveal about the early universe. Lyman alpha emissions are created by the transition of electrons in hydrogen atoms and are typically observed in the ultraviolet spectrum. However, due to the expanding universe, these emissions are increasingly redshifted from our perspective, altering their light waves optically. Fortunately, this effect allows us to capture and study these emissions more effectively. The JWST is ideally suited to detect these redshifted waves. Lyman alpha emissions, or LAEs, serve as a silent beacon for scientists studying the earliest phases of the universe. They help astronomers examine processes in galaxies that occurred just a few hundred million years after the Big Bang. This era is believed to be when the first structures in the universe formed, making LAEs crucial messengers from this period. However, these emissions may also challenge our current understanding of the universe. With ongoing discoveries, we are questioning the validity of the Big Bang theory and considering alternative views. Researchers aim to use LAEs to investigate the reionization epoch, which was thought to follow the Big Bang. According to the previous model, the universe underwent the so-called Dark Ages, a time without light due to the absence of stars or galaxies, and where light could not penetrate the dense cosmic medium. The transition to a bright, light-permeable universe was believed to mark the reionization phase. LAEs were thought to be pivotal in this process. But if the Dark Ages and reionization did not occur as previously thought, researchers may have misunderstood the role of LAEs. Thanks to the latest discoveries from the Webb telescope, the picture is becoming clearer now. By studying LAEs, scientists can better understand what was going on in the galaxies Webb shows us. LAEs provide reliable information about how many new young stars have formed in galaxies and how the intergalactic medium has behaved during this epoch. By studying LAEs intensively with the latest telescopes, scientists will continue to gain more information about star formation rates in early galaxies, and this data will help us piece together the puzzle. Eventually, we will know if these galaxies are really baby galaxies in a young universe, or if these galaxies formed in a completely different way and are much older. The images provided by the JWST reveal galaxies that are remarkably starry and bright. To fully understand what is happening within these galaxies, we must utilize every available source of information. Another powerful telescope, the Vera Rubin Observatory, will soon be launched to offer even greater clarity. Currently, we know that the strength of Lyman alpha emissions often indicates the level of new star formation. These emissions also originate from star-forming regions that are significantly younger. By measuring and analyzing these emissions, scientists can quantify star formation in early galaxies and draw conclusions about the processes behind their formation and evolution. The JWST continues to discover more Lyman alpha-emitting galaxies, achieving remarkable results. It has managed to observe further back in time than any previous telescope, revealing impressive examples of Lyman alpha emitters critical to current research. A notable discovery is the galaxy GN-Z11, first identified by the Hubble Space Telescope and later confirmed by the JWST. Despite Hubble's data, researchers initially doubted the galaxy's existence due to its age, around 400 million years after the Big Bang, which was already unusual at that time. There were concerns that it might have been a measurement error or an anomaly. However, the JWST has confirmed GN-Z11's reality and validated Hubble's findings. The JWST spectrometers reveal strong Lyman alpha emissions in this galaxy, highlighting its intense star formation and marking a significant shift in our understanding of how galaxies formed in the early universe. Another significant example is MAC S0647-JD, a galaxy found in an early galaxy cluster. Despite being extremely faint and in a very early phase of the universe, JWST observations reveal that MAC S0647-JD exhibits strong Lyman alpha emissions and is producing a substantial number of new stars. This galaxy shows surprising activity for a galaxy that is both faint and presumably small. Additionally, the galaxy EGS-8P7, located approximately 13.2 billion light-years away, also displays unexpectedly strong Lyman alpha emissions. These emissions imply that EGS-8P7 was capable of generating bubbles of ionized hydrogen around itself, allowing the LAEs to escape. The continued bright appearance of several galaxies from this theoretical epoch raises questions about the accuracy of the reionization model, as there are no signs of the expected cosmic darkness. Regarding the most unusual black hole discovery, let's closely examine the galaxy GN-Z11, which existed about 400 million years after the Big Bang. A supermassive black hole has been detected at its center, challenging existing theories about the formation of such massive objects in the early universe. Previous models suggest that supermassive black holes form through the collapse of massive stars or the merging of smaller black holes, processes that should take billions of years. This finding raises significant questions about the validity of these theories and what it reveals about the early universe. We must consider that alternative mechanisms for the rapid formation and growth of black holes might exist. One theory suggests that these black holes rapidly accumulated mass through direct accretion of gas in material-rich regions of the early universe. Other theories propose that unknown forms of exotic matter or energy could account for their rapid growth. It is surprising that so few scientists are prepared to dismiss the idea that the Big Bang may not have occurred or that it happened much earlier than previously thought. Conservative science remains committed to reconciling traditional views with new discoveries by seeking explanations for this accelerated formation. Lyman alpha emitters are expected to play a role in this investigation. However, what evidence supports the idea that the universe might be much older? The presence of an enormous black hole in the galaxy GN-Z11 suggests that the dynamics and evolution of galaxies observed by Webb are similar to those of today's galaxies. Other Webb discoveries also reveal structures indicative of a universe that was already highly evolved, just a few 100,000 years after the presumed time of the Big Bang. The scientific community is actively engaged in this debate, with some researchers aiming to validate the Big Bang theory and its associated concepts, while others are striving to use Webb's findings to support alternative theories. And that's it. Thanks for exploring the cosmos with us on Spaceverse. From the groundbreaking discoveries of the James Webb Space Telescope to the mysteries of early galaxy formation and the enigmatic Lyman alpha emissions, we've delved into how our understanding of the universe is evolving. Stay tuned as we continue to uncover new insights and challenge old theories about the universe's history. Don't forget to subscribe for more stellar updates and in-depth explorations. Until next time, keep looking up.